So we'll talk about quantitative research methods today. And we so far have some idea about quantitative research methods. Now, what is the first thing to know about quantitative research is what is it? So what is quantitative research? A systematic and rigorous investigation that involves the collection and analysis of numerical data. So anything that involves analysis of numerical data, any method, any technique that falls into the quantitative research. So it aims to quantify relationships, behaviors, or phenomena by converting observations into measurable units. So you have three types of things: empirical, quantitative research, so that relies on observation or experimentation rather than theoretical speculation. So if you have, this is like when you are making tea, right? You don't need to necessarily, now some of you might be still using sugar when you are drinking tea. So when you are comparing, the sweetness, the amount of spoons, the amount of scoops that you have to put into the tea. You don't have a measurement, but it's empirical. If you are cooking, the amount of salt that you put, some experienced people in the kitchen, they know how to put that little, pinch of salt by experience. So that is empirical. It entirely relies on observations or experimentation. And in the case of structured case, so it follows predefined systematic procedure to ensure consistency. So in that case, you have to follow a certain lab manual, or there is a technique previously defined. So that is mainly because of the reproducibility and the reliability. So someone else can also follow the same structure, same idea, the same method, and then repeat it. In the case of empirical understanding, it is rather difficult to transfer the knowledge because it is not measured or structured. It only follows that experience of the researcher. In the case of structured, you can actually reproduce it because you have some sort of a consistent structure of the technique. There are empirical research that can also be followed if you are into the area of like civil engineering or chemical engineering. In some cases, you need to rely on your experience, your judgment to mix things, to find out the consistency. Like if you are baking, you know that the baking, the substance, the flour, and the mixing has to have certain consistency. It is very difficult to say how it is, but you have to do it and understand how it actually looks like. Now, that is empirical observation and empirical understanding of research. When it comes to objective research, it reduces the researcher bias by focusing on quantifiable and verifiable evidence. So it increases the validity because the researcher is not involved in the decision. But in my opinion, if you philosophically argue, it's rather very difficult situation uh, to say like what is objective, because in that case, if you think about an objective mechanism, then you cannot totally negate the researchers' understanding of the phenomena. So you cannot be entirely objective, and it's somewhat philosophically difficult to achieve. But still, there are things like if it is a value that you blindly follow, not blindly, but there is a certain objectivity involved in it. So there are things like that in like decision theory, like you look at the math and you look at the statistics, and then you entirely base your argument on that. That's objective. So we have statistical analysis in quantitative research. The first one is descriptive statistics. I think that is what we usually, every day we use descriptive statistics. Like if you look at the expenditure for the month of April, for example, and find out the total expenditure, divide by 31 days, you will get the mean expenditure, the daily expenditure for you in April. And if you get the median, like the largest, and if you order them and then find out the like 30, if it is every day that you are looking at, so you have 31 observations, right, in April. Sorry, April only have 30 days, so 31 or 30 days, and then 30 plus 1, and mid value would be 15.5, and 15.5 means 15 and 16 values, and the mean of that. So that's the median. I will come to these things in the next lecture anyway. So next lecture means not today's one, the lecture after that. So we'll talk about these statistical measures anyway, but I'm just giving you a rough idea of what it is. And the mode is, if you take the April expenditure, you can find out if you have a particular expenditure that you repeatedly do. For example, let's say that you come to the university from your boarding place or your home, then maybe you're coming from your own vehicle, or maybe you're using a bus or public transport. If it is a normal day without any other expenditure, you will incur the same amount, maybe 1,000 rupees. So if you have 1,000 rupees repeatedly for more, the frequency is high, and that becomes the mode of your expenditure for the month of April. So these are like descriptive statistics, some measures. It's summarizing the sample data. And the next one is inferential statistics. Here, what we do is, even though it like states hypothesis testing, regression analysis, what it really does is you have a set of values. So, like your April expenditure, the minimum standard, and all these values in the April expenditure. So, you infer about the entire expenditure. You can extrapolate, you can infer about your own expenditure, or you can be more generalized and think about you and in the context of all of the people in your cohort, in your sample, in your cluster, maybe all graduate students, their expenditure. So that's inferential statistics. You can take sample value and then conclude about the population. That's inferential statistics. In the case of predictive modeling, what you do is you fix a model that describes the behavior of data, and you use that for forecasting the future outcomes, because you have an abstract model which uses the data, and then the model itself will give you the final answer following the model predictors, the equations, and the model fitting that you derive from your statistical fitting. So that's predictive modeling. Pretty much like most of the mathematical equations, the research equations that we use, like F equals ma, even though it's a physical equation, in one way it's predictive, because you can tell about the force if you know the mass and acceleration. So if you have y equals mx plus c kind of an equation, then if you know the x value, if you have already fitted the model to find out the c and the m, then you can get y when you have x. So that's predictive modeling, the forecasting of outcomes. So three things: descriptive statistics, inferential statistics, and predictive modeling. We can actually go into very detailed things about this, like you can talk about prescriptive analytics, predictive analytics again, descriptive analytics. So a lot of things associated with that. But in terms of the statistics involved, we will be here. We will be on these three. So the objectives of quantitative research: we try to quantify variables and their relationships in numeric form. That's what we try to do. So if you think about a research question that you have, right, you have to convert that, right, quantify them and their relationships into the numeric form if you want to do quantitative research. And in other words, if your objective itself is to put them into numeric form, then you have to follow quantitative research. So in simple terms, let's say if you have a coin, right? This coin, if it is head, you give 5 rupees. If it is tail, you receive 10 rupees. So if you play this game, how much you will earn after 10 successive flips. So if you want to find out that money, that amount that you may receive, probabilistically, you have to associate the head and tail with the amount you give and amount you receive. So this is basically coding the variables into the probability values, what we call random variables. We will talk about in the third lecture. So this is quantifying variables into numeric form or probabilistic form in that case. But basically, this is the thing happening. Identify patterns, trends, or causal relationships within data. Generalize findings from representative sample to a larger population, enabling broad applications and evidence-based decision making. So these charts I have included to show you like different types of things that we can expect. In the chart A, the AB has a positive relationship because the incremental of B will result in an increase in A. In the case of the chart B, this is a negative relationship. Increasing D will result in a decrease of C. So that's a negative relationship. Now, if you think about C, C doesn't have any proper relationship. So it is spreaded. It doesn't have any particular correlation. So even though we did a quantitative research, we cannot, in this case, generalize the finding based on a linear relationship. So we have to find a different way. In this case, there's a slight grouping, and we might need to find out. This is in many cases, this would be a classification problem, like higher values. Let's say in the case of H here, higher values of H group the values of G into some cluster. Lower values of H group the values of G into a higher cluster. So this is a classification. This can be a classification problem when you look at the data. So it's something that you have to decide. Now, we look at quantitative research methods. What are quantitative research methods? So we probably would repeat these things here and there. So don't get overwhelmed if we keep on repeating some of these things. It's basically the structure of the presentation, that's all. But all in all, these are some of the key things that we find as quantitative research methods. So you have experiments and quasi-experiments, control procedures to test hypotheses by manipulating variables. And then you have behavioral measures, right? Systematic observation and recording of human behavior. So you go to the canteen, for example, right? And then observe how if you go there, like Sherlock Holmes, for example, if you observe the first years, second years, and third years, and fourth years, you will understand how they behave. Sometimes the first years would be a bit timid, shy to approach, and they would be perhaps buying rather not that expensive items from the canteen. But fourth years, immediately after the let's say the training period, they would maybe buying something expensive because they have some money. So that is simple observation to understand like human behavior and to identify maybe which class they belong to. It's behavioral measures. And if you look at questionnaires and surveys, which I think one of the key focus of this presentation and the next presentation, it's structured instruments for collecting data from a defined sample. So there's a sample and we collect data from them. And then we have social network analysis. So what do you mean by social network analysis? So in the case of social network analysis, we map the relationships between entities, which means, let's say you have a connection. Think about the Mudalali, the person who is doing a grocery shop at a village. So many people will be known to him. because all of them will come to the Mudalali to get something in the village. In the village, the villagers will somehow, in any way, would be connected to the Mudalali because he is the one who is doing the business there, and everyone would come to that shop to buy maybe soap, maybe toothbrush, maybe the newspaper, to read newspaper, or to buy some other items like sanitary items or anything. So if the shop is the only thing that is available for the villagers, the Mudalali has high density of connections because he's a node. Many people will be connected to him. And if you again look at the Hamuduru, the monk at the village, so I refer to he because most of the monks in Sri Lanka are uh, male. So he is connected to many people from the village, the so-called good people, and also so-called bad people, because some people would come to the temple, or if it is a Catholic area, to the church, the pastor or the father. So mainly the church will have a father. So they will be connected to good or bad people, but they are social in the sense of social network. They have a high weight. So if you that's something like a social network. But if we map and measure relationships between entities, you can find some connections and some hidden patterns. Who knows who and who is closer? If you want to do something, perhaps maybe rather than going through the longer channel, you might find a shorter channel. A person who is known to you would be there in that network. So that's what a social network analysis would look like. Then you have archival and meta-analysis, where we analyze existing records or synthesizing findings from multiple studies. This is one of the very interesting studies. Like you can go to do historical findings, you can go to do heritage studies like archivals, read the Pali scripts, the old scripts in a church, or go to Vatican and read the archives if they allow you to do so. You can be like Tom Ryder or like Sydney from that very old TV series. I forgot the name. I forgot the name. So, those are like archival studies. You can go and read the things about history, about many things. And then meta-analysis, of course, it's a statistical analysis to find out the norm of the studies, where we can find out, let's say, for example, different universities, let's say about Colombo district. In Colombo district, there are a lot of schools, very good ones and very poor ones, very bad ones. So very good. So I'm not always referring to good and rich. Say good schools are there, good and rich schools are there, good and bad schools are there, good and poor schools are there, and bad and rich schools are there, and bad and poor schools are there. So there are four categories if you look at it in that way. In a meta-analysis, what we can do is we can find out what is the general, the average marks for the mathematics for grade 10, for example, and then we can do this analysis to find out what is the average and how what to be expected of these schools, and whether actually the good schools are doing better than the bad, so-called bad schools. So that's something like some example for a meta-analysis. Let's go forward. So we deal with these laboratory and non-laboratory procedures, and all of them involve a measurement. So any type of a measurement. So it's a quantifying variable, the quantifying particular variable precisely. So it can be a height, weight, temperature, some scaled measurement about something like an opinion. It can be a taste, for example, whether it's tastier than something else, a comparison. So it's a measurement. And all these measurements are important to do the quantitative research. Without measurements, you cannot do quantitative research. Then you have population and sampling. I'll talk about population and sampling in the coming slides, so I'll stop it there. And then random assignment, assigning participants without bias. So it's like giving a drug. So you make a drug and you give it to different participants without thinking about anything. Like you give it and check what happens. So that's random assignment. And then generalizability. That's what science is all about. When we write the conclusion, we conclude the study, but when we do the discussion, we try to generalize the discussion so that it has a more breadth and depth of your study. So it's a generalizability of your work. And in the conclusion, maybe in the latter part of your conclusion, we can write as a general statement how these findings can be applied in the general context. So if you look at an abstract as well, the last two sentences, they probably the hint would be towards that generalizability, what to expect from this study, this type of studies, and what you actually conclude. So what your study is actually contributing, it's generalizability. We talked about time dimension as well last time, the cross-sectional studies and signal experiments, one point in time, longitudinal studies, they are repeated in time, across the time. Okay, so let's look at the experiments and quasi-experiments. So these are some of my own figures. I captured them in one of my lab experiments. So what do we do in an experiment? An operation or procedure carried out under control conditions to discover an unknown effect or law, to test or establish a hypothesis, or to illustrate a known law. So if you take a look at these figures, I will explain the figures so you understand it better. In this particular apparatus, this is a custom apparatus which we build to hold these glass beads. So these are glass beads. 3 millimeter and 5 millimeter glass beads are there. And at the center, there is a carefully developed sample. It has a particular particle size distribution. So different particle sizes, it's a known distribution. And what we do is we put it into a compression, a known compression with the weights of the column. And then we have a pressure gradient applied from the top to bottom. The water flows through the sample, and there are sensors associated with these little nodes here. So we capture the pressure values. So we can find out the gradient across the water flow, the pressure gradient across this device. And the D is about a CT, this is a micro CT scanner. So what we try to do is we try to look at the inside of this pore space or the connected porosity of this sample. So we know how water flows through it, plus if the particles get trapped inside this pores. So that's the idea of the research. So the hypothesis was that under certain temporally changing pressure gradients, particles tend to coagulate or create bridges in the entry points, exit points of these locations, with creating preferential flow paths. So that is the hypothesis of the experiment. So what we try to see was how this bridging occurs in this connecting layer. So that's the idea. So I put my image so that I can explain what actually happened. So the idea, it's a controlled empirical test of a hypothesis, and to deliberately vary something in order to discover what happens to something else later. So the change that we applied here was the pressure gradient, the difference between the water pressure. So we change it with a known temperature, known temporal pulse, which means for every 2-3 minutes, we change the pressure to see whether bridging and unbridging happens in these interfaces. So to seek the effects of presumed causes. So the clogging and unclogging, that's what the technical term is. If you think about this, that is known in many research, in different types of research. In medical research, you have clogging of your arteries and blood vessels. In pavements, like roads, you have this water going through the pore surface, clogging and unclogging happens. And if you think about the baking, cooking, many other places, this clogging, unclogging happens. So that's the general idea. So we knew the movement, how it goes. So we were trying to understand through experiments how this phenomena can be related to the variation of the pressure. So that's what we were looking for. So an experiment is a controlled empirical test of a hypothesis. So the hypothesis include A causes B. So for example, if I go back to that experiment, the pressure variation causes clogging and unclogging. So we have a pressure variation, it causes clogging and unclogging. And if you look at A is bigger, faster, or better than B. So these type of things, like for example, if we develop different types of samples with different compaction, the higher maybe the type of compaction A is better than compaction B when it comes to preferential flow channel generation. So that's hypothesis. Then A changes more than B when we do X. So that's, again, if I look at my own work, it says the preferential flow channels, the occurrence, the frequency of preferential flow channels happens or changes more in the case of this compaction than in the other compaction, or in here than here, when we change the pressure variation. So there can be multiple correlations that, or causations that we look for. So based on that, we can develop hypothesis. So there are requirements, an independent variable that can be manipulated. So what we did was, in this experiment, we kept the particle size distribution the same. So that's the independent observation. So that doesn't change. It is the one that we keep, and with time the structure changes. So a dependent variable that can be measured. So we measure the pressure, and we observe the pore structure to connect the connectivity between our hypothesis and what we observe. So why do we experiment? We experiment to update our knowledge when there is uncertainty regarding the state of nature. So think about a simple thing that you did as an experiment, not scientific. Think about what did you do at home, for example. Maybe in a bus, to understand something was changing, you did some variation and see how it reacts, to understand how it changed. So we must concern ourselves with situations where the consequences of a decision depend on some factor which is not known with certainty. So there are cases where we don't know what is happening. A set of possible decisions need to be taken, a set of uncertain events like the state of nature and the resulting outcomes. So these are the things where we actually look at, right? Which is not, we don't know. So we have to do certain things. So if you do this, if you look at the same experiment that I was explaining to, we had to do a lot of things in order to come to that point, because there were so many things like which hindered the experiment, because the water was not water was leaking, right? The instrument was leaking. The instrument had some issues. The glass bowls were not spherical. The particle size distribution was not uniform, or the way that we were looking at it, we were intending. So there were so many issues, and we had to look for that, and we have to make sure them and we have rectified them. Then categories of decision making: decisions under risk, probabilities of outcomes are known. Decisions under uncertainty, probabilities are not known. No competition, outcomes depend only on passive forces of nature. Competitive situations, outcomes depend on other decision makers. So this is why we do experimenting, because to basically, if you ask me why do we do experiments, I would say because we as a species are afraid of uncertainty. That's why we do experiments. So we have this tendency to understand what is happening in nature, and we have the desire to predict, so that we can be rest assured, we can be happy about our situation, because we can understand if there's a threat, if there's something going to happen, we can we are aware of it. So that's why we do experimenting, and all these things are there. So because of that, we try to do experimenting, try to develop data, do the analysis to find out certain, to develop an understanding about the world. Right. Experiments in research are the things that can be manipulated, common research application, comparing one design or process to another, importance of particular feature, technology or social intervention, what really causes an effect, and if an effect really exists. So these are some common applications. Of course, you are graduate students, so you know better than me at this instance. So you can think about many other ways in respective domains, areas of your interest, how you actually do things. Right. So types of experiments. Now, randomized experiments. So when I refer to these experiments, they are not necessarily in lab-based experiments. There can be other cases as well. So randomized experiments can be units or participants, both, like social research type participants also there. They are randomly assigned to receive a treatment or an alternative condition. Provides the strongest evidence for causality. So why something is happening? Is smoking leading to cancer? Simple question. And to make that causation, to understand what is actually happening, you have to do a lot of research to do these randomized experiments on different type of individuals or different types of units to find out the outcome, to find out the causality. And when you think about quasi experiments, there is no random assignment, right? It is not random. Groups are formed based on pre-existing characteristics or voluntary participation. So in my experiment also, the experiment that I showed you, in the lab experiment even, we could not test all those possible particle combinations. They are very complex. So we have to make sure that we set ourselves into a particular type of arrangement, and to understand maybe those who are familiar with particle size distribution may understand that uniform particle size distribution, the same size of particles, to make sure that the lines and the pore space is uniform, and so on. So we had to make sure that there's a pre-existing characteristic that we want to keep, right? Then natural experiments, these are some of the very interesting things, like you look at a naturally of occurring incident, intervention has been implemented, but the circumstances surrounding the implementation are not under the control of researchers. So disaster-based research, that's also one area that I'm looking at. I'm currently working on. So you have a disaster, and the disaster is like the entire world is our lab. If you say it in a very bad way, that's kind of sadistic and super villain kind of an idea. But the entire world is there, and the natural occurrence is there, and we observe. So when you do satellite images, we take the image and try to understand after and before an event, a flood event or a forest fire, or something like that. So that's a natural experiment. It involves large scale observations. Right. So I put more emphasis on experimentation and the techniques that we do and types of research experiment techniques. Then we go to quantitative data collection methods. Okay. So this is going to be an interesting section. So I hope you pay your attention to this, and we have 43 participants. And if you have any concern, please send me a chat message. I'll because if you open the mic, sometimes you forget to switch it off, and can be echoing. If by all means, if you can switch it on and off, interrupt me, no problem. So quantitative data collection methods. The very famous one, when you think about a group of people or social and business research involving participants, unlike the experiment, you have surveys and questionnaires. So you have structured instruments used to collect data from a sample population. So what is a sample population? We will discuss in the coming slides. But this is what you do. You take a sample and you focus on one element of that sample. So this is one element of the sample, and then you do a questionnaire. So to give this feeling, that is why I shared that dummy or sample questionnaire with you. So you are subjected to that question set. So once you interact with it, you understand the issues that you face as a respondent, and also the ways that you can do it better. That's the whole point of it, and not to collect your data. And I don't necessarily deal with those type of research. I don't care. So I just wanted to give you how questionnaires and surveys would impact both to the researcher and to the respondent. Right. So you have structured observations, systematic recordings of observed phenomena using predefined categories. So naturalist observation, like the things that you see in the nature, or discovery observational method, in which in this case psychology, for the example image, psychologists observe the behavior of subjects in their environments. So you look at children in classrooms, you look at university students in the lecture halls, and you will look at general public in their own interactive environments, maybe the Sunday fair, or maybe in the bus or the train. Laboratory observations, on the other hand, where you observe the behavior of subjects in a closed environment, in a fixed controlled environment. There they are given only limited things to interact with, and they are fixed. So that's the structured observations. That's you can have a different structure, but anyway, these are observations. So this is something I did for fun. So you can actually do, you can go and check that you can create your own name using Landsat images. So I just put it there to show you. Secondary data analysis involves collecting data from satellites, from government archives, or from sensors. You can find many other places where you can collect data. So the image you see, this is my name, and the data was the data set was collected from the Landsat. So it's a satellite observing platform, Earth observing platform. So you can see the name and the shapes of the name is in these are naturally occurring shapes, but these are images taken from satellite. So just gave you this thing to remember that secondary data means using whatever existing data sets, government records, databases, or published data, even research themselves. Like one research doesn't mean that's the end of the world. Maybe you can collect data from the published research, published papers, connect them, and then reanalyze the data, maybe based on something else. So the meta-analysis is used to do those kind of things, but you can also collect data and do it if it is like quantitative research, where you have recorded values like this. So quantitative data collection also can be considered under modeling, simulation, and emulation. So the images that you see, right, these are some very interesting things. So I'll start with my own image, the left-hand side, this one. So remember that apparatus where we have glass particles, glass beads, the soil particles, and then the glass beads. So what you see here is it's one cross-sectional image, a 2D image of that CT scan that I was talking about, how the pores are connected, the chains of connected pores. So if you look at this line, for example, this is an isolated pore, but you can see the preferential flow path. If you look at these connections, see, they go all the way connecting the path. So this is one path. So this connected pore path is what I was looking at, how the application of variable water pressure is changing this, but this is 2D, right? So how did we do this? We actually model the pore structure using different, we don't need to go into techniques of it, but we use the images, the CT images, and then we have some mathematical understanding about the pore structure. So we converted the spaces, abstract the image, the abstraction of the real world, because these are not like the little, the spheres, they don't appear in the real world. What we did was the openings and the connected pipes were developed as models, the mathematical models of the connected pores. And that's what we call modeling. So that is just part of one type of modeling. There can be many other types of models, statistical models, equations, many things, right? And then you have simulations. So what is a simulation? Simulations, so just to get your views, have you done simulations in your current research or undergraduate research? Can you send me a message? Simulations, how many of you have done simulations in your undergraduate work or now currently doing? Okay, one. We got one response. Any other? Got just one response. Others, if you have not done, you can say no if you like. Okay. One yes and one no. I hope others are also listening to us. So simulations, what they do is you um, you have a set of equations about or some understanding about the world given in equations, right? It can be now. Bear with me. I will explain this in physical terms. So imagine that there is a flow equation like this name may not be familiar to you. Some of you might be aware of this name. So this is called, there's an equation called Navier-Stokes equation. So let me show you that. Let me try to, yes. Uh, let me show you this. I will show you what a simulation is because it's easy for everybody. So let me take. Right. Okay, this has to be minimized. Go to next desktop. Right. So this is what we call Navier-Stokes equation. Okay. So forget about, just don't worry about the mathematics involved in it, but I'll explain what a simulation is. So this is Navier-Stokes equation. It's a set of equations, like it's not one equation, it's an equation set. It has partial differential equations that describe the motion of viscous fluid substance. Forget about the words, but what it basically does is, if you have water flow and the Navier-Stokes equation, so there was a big thundering. Can you hear my voice? Is the internet connection working? Can you hear my voice?
Yes, sir.
Okay, right. I'll try to explain it very quickly. I think the electricity went off in the university. Okay, so I'll explain it very quickly. So this is the equation. There are components of this equation. There are vectors and differential equations. So what simulation does is, to solve this equation, you would need like, there are no solutions to this equation. You can't, this is just it's very abstract understanding of the movement, conservation of momentum and conservation of mass. A lot of things are there, but these are like, what we call those essay type, like there's a big essay of it, but no solution. Even though it looks like an equation, it is not a solution. It doesn't have a solution. So what we do when we do this flow, what we call simulations, is we give numbers. We give numbers to the pressures, inertia, like the mass and all those things. We give little numbers, starting points, and then we change the values incrementally, maybe 0.5, 0.2, 0.6, like that. And every time we do, we put the values into these equations and then try to find out, to calculate what is happening here. So if you look at the base simulations, so these are some of the simulations. This is what we call simulations. So this is 2D Navier-Stokes. This is what we call simulation. Internet might be off, but anyway, we don't need sound. So these are simulations. So you have the Navier-Stokes equation. These colors are given later, okay? But what we do is we solve the equation along these different points, different points along the x and y axis, and the solutions will give you values like pressure. Here in the compressible Navier-Stokes equation, you look at the pressure variation, etc. So these are called simulations. So you can see other examples as well. If you are interested, please watch these videos. They are very interesting. Like number pile one is very interesting. So look at these things. So these are what we call simulations. Okay. So these are simulations. Okay. Now let's go back to our lecture. Let me close that first. So then, where were we? Simulations. So these are called simulations, right? Now, what are called emulations? Have you heard the word emulation before? Now, simulation is what we, discuss right now. We have equations, we give values, and we give incremental values in time or space. Try to find out how the system works. So it's very computer intensive. You need a lot of calculations. So that is simulation. What is emulation? Have you heard of this? If you haven't heard of the word emulation, you can say no. If you have worked with emulation, please say yes. What is an emulation? Okay. So what is emulation? In the case of emulation, what happens is you produce exactly that system. So these are mostly found in computer systems where, now, what is a computer system? Now, if you look at a computer, we have a RAM, we have a CPU, we have this computer monitor, inputs, and all these things. We can create this in virtual environments. We can entirely create this digitally. So that is what emulation means. So we reproduce or duplicate the functions of a system in a way that is functionally identical to the thing being emulated. So this is very important. Functionally identical. So simulation, in the case of simulation, we use equations, we try to mimic physics, we try to do that exact thing. It is very complicated and computationally intensive. So what we do is we try to solve these equations and simulate the world. In the case of emulation, it is sometimes more complex than simulation. Because in the case of emulation, you have to exactly develop the system, functionally identical system of the thing that is being emulated. So those who are working in electronics engineering or systems in computer cybersecurity, you can read about this emulation. So if you are interested in, just find what is emulation. So this is emulation. Use a software or hardware to make one computer system in terms of computers behave exactly like another, enabling the execution of software such as video games, operators. So this is the case of software, but it is there in robotics and in mathematics as well. So emulation of a physical system. So emulation of a physical system. Functional replica that behaves exactly like the target system, allowing it to act as a substitute in real time. So if you want to remember what is an emulation is like this. You have seen voodoo magic, right? Like this. So if you were in love with someone or you wanted someone and that person is no more, so you have the doll exactly like him, and then you do things. And this is theoretically functionally similar to what you so that's the idea. So I mean, it's not the idea, it's word magic, but the idea of emulation is like that. The system is identical. Okay, let's look at without spending too much. What is a population? Sample and sampling. So a population is like this. So you have a statistical population is usually defined as a collection of all possible observations. So I just took this image. So it doesn't mean that all possible observations, but imagine like this is like a population. You have all those things and of a specified characteristic of interest. So in our all acceptable range, we'll say the population of women or females. And a population can be finite or infinite. So in the world, because the Earth is the only known world to have females, so we can say it's a finite. It's finite. It's not infinite. And also it's a quantitative population. So we can count all the females in the world. Now let's go to the next one. That's population. But we cannot go and collect measurements or observations about all the females in the world. So there is a target population. What do you mean by a target population? The entire group the research aims to study. So that group may be working females aged between 25 and 35, for example. So that is our target population. That's the entire world population. So who you care about, theoretical and huge. So if you think about the female population, 25 to 35, there's a lot of females, right, all around the world. Then we have, so I given this little example here, all people in the country who have purchased and drank this specific organic coffee in the last year. Think about that as an example. So let's go to the next one. Then there is accessible population. The accessible population is a realistic subset from which data can be collected. So you can actually reach realistically and you can look at this localized sample. Now, customers who purchase the coffee from a specific major grocery chain, like Barista, for example, and are members of their loyalty program. This is important because we can observe all the people who are getting coffee from Barista in this example, but we need to be accessing the information. So the population should be accessible. That's what accessible population is. It's a realistic subset from which data can be collected. We can collect data, right? So I have given you this little example, like you have all the people in this population, but we have a particular set of people who are accessible. Then sampling frame, a comprehensive list of the accessible population. So this is the accessible population. Then there's a comprehensive list of that sampling frame, from the frame in which you use to sample from. The actual list of names, concrete and operational. So that's your sampling frame. The specific database of 5,000 loyalty card members who have organic coffee brand X in their transaction history. So that's accessible, and that's our sampling frame. Specific database of 5,000 loyalty card members who have this particular organic coffee brand. Okay, so that's our sampling frame. Now, sampling frame doesn't necessarily mean that you go and talk to all these people in the sampling frame. We need to go for a sample. A sample is the collection of observations representing only a portion of the population. So we look at this. So we end up getting 5,000 loyalty card members who have this organic coffee brand X in their transaction history, but we don't go and sample everybody. We don't do that. We don't go to everybody. We only have to select a portion of the population. That is where we experience this probability, the problem of probability sampling. Sampling reduces the cost and effort, because if you go to all these 5,000 loyalty card members, if you think about even these girls, will be very expensive, right? You have to go everywhere. Not all will be happy to participate. That's also another issue. Not everyone would be happy to participate in your research. So sample means the reducing cost and effort while still enabling inferences about the population. So we do the sampling in the hope of inference. We want to infer about the population. That's why we do sampling in the first place. So we do it in the sampling frame. So it's essential for accuracy and reliability of findings. Small sample, unreliable results. Excessively large sample will be very high cost. So if you are rich enough, like, you can access all these data points, all these elements in the population, then you can go for a large sample, which usually like Facebook, Instagram, and all these places can do, because it has all members of the society in their samples. So it's very high cost. But small sample is also unreliable, because we may not be capturing the dynamics of the actual problem. A proper sample size ensures generalizability with acceptable confidence and precision. We'll talk about this in the third and fourth lecture and so on, how to define the sample size and how to generalize from there. All right, let's go to, now we talked about the population, we talked about the sample, and the issues associated with sampling is the probability, because when we have a sampling frame, we have to pick samples from that sampling frame, right? When we do that, we inherently have a probability to choose from. So each population element has a known non-zero chance of being chosen for the sample, right? So anybody can be the pick. It has a known, so when I say when we have that specific sampling frame, we have a non-zero probability to sample, and each element has that chance because it's inside that sampling frame. That's what it said, non-zero chance of being chosen. Now, if we go further, the simple most method is simple random sampling. So each member has an equal and independent chance of selection. So we have a sampling frame, the organic coffee drinkers of that particular chain, and 5,000 of them were there. So we just randomly select without any consideration. So everyone has an equal probability. So an independent chance of selection, ensuring unbiased representation. So that's simple random sample. You go there and you keep on sampling from your sampling frame, simple random. Now, in the case of stratified sampling, what we do is we divide the population, not the accessible population, the sampling frame, we divide it into subgroups, strata. So you have to be very careful when you are selecting the sampling frame as well, because sampling frame is not your subgroup. Sampling frame is the population that captures all the things that you need in the population, in the accessible population. So don't get confused with this. Once the population itself has these subgroups, the strata. So it can be based on color, height, gender, income, many other things if you look at a population. So population itself has these strata, the subgroups. And we use this stratified sampling to sample from these groups or these stratas, randomly sample from each subgroup. So here, the probability of one being in the strata dictates also that chance of getting selected, because look at the colors here. If you are not really looking at the girls, look at the colors here. So you have different colors. So you have purple stratum, the red or magenta kind of stratum, and then the ash color stratum. So you have two from this, one from this, and two from this. So that is your sample. So that's probability, because you have 4 here, 4 here, and 4 here, but you only sample here. This is not from the probability distribution or as such. You randomly sample from each subgroup. So that is also there. You can be more systematic as well. You can sample from each subgroup, say 2 from each category like that. So that is stratified sample. Whenever you do the stratified sampling, you have to have a subgroup. So there is in the population, there is a certain class, certain variation, certain label associated with that strata. Then you have cluster sampling, population divided into naturally occurring groups, schools, neighborhoods with random clusters selected for data collection. So in machine learning, we call these like KNN clusters and clusters based on their own data types. So the population naturally occurring groups, right? You can think of it. So if you look at the girls example here, it can be their ethnicity. It's naturally occurring. You can find that cluster. Then you have systematic random sampling. Every nth individual selected from a list after a random starting point. So it's like that. Now, for example, we find these people in our university batches as well. Like you start with one girl, and then if it is a boy, and then you go for like nth individual selected from the list after random starting point. You start from somewhere, and then you select another person after counting 3, 4, or whatever the number, and it keeps on going. There's a system, but it's random, systematic but random, because you have a number of sampling from a particular group, a particular way of sampling, but the selection is random because the starting point is random. So that's what systematic random sampling is. And then multi-stage sampling method where population is selected in multiple stages. So you have started with large clusters and then you go narrow down. Stage 1, 2, 3. You can read the slide. I'll upload the slides today. This is from the previous lecture, so I'll quickly go through it. Okay, so this is non-probability sampling. So we do not know the probability that each population element will be chosen, and or cannot be sure each element has a non-zero chance of being chosen. Okay? Read that carefully. In the case of voluntary sample, what we do is individuals volunteer. Now, if you immediately see this image, uh, while I do this, I want to listen, get your comment on this. Have you seen this image? When you see this image, you remember the video and all the things associated with that. So it's a volunteer in the response, and it's an open invitation, and the person responds. So that's voluntary sampling, can be really dangerous as well. Good and bad both can be there, because the participant voluntarily, he or she joins the sampling programs with his consent. So it's an open invitation. So these type of things can be like questionnaires. We share those things with anybody. They can come and give their sample. And then convenience sampling, selecting readily available subjects without randomization. So we don't necessarily go into the other people in the population. We only focus on whoever accessible. That's convenience sampling. So readily available subject without randomization, easy and very low cost. But if all the people that we know, or we can conveniently access, then we probably be biased with our outcomes. So because they are not really random, or they don't know, maybe they are subjected to the condition that we also are subjected. So we all see the same thing in the same way, but not the real problem. So we cannot capture the hidden hidden issues in the sample, or hidden issues that we have to deal in our research. Purposive sampling or judgmental sample is intentionally selects participants based on specific characteristics relevant to the study. So it can be like fishermen. Now, in this case, cats. I have selected these people, so purposefully. So I decide what is the characteristics. It can be doctors in the neighborhood, can be janitors in the neighborhood, drivers, anybody whose specific characteristics are relevant to the study, and we intentionally select those participants, right? So that's very specific. So that's why purposeful, judgmental, purposeful sampling. And then we have quota sample, selecting subjects to represent specific characteristics or proportions within the population. So there is a certain proportion of characteristics or proportions within the population, let's say ethnicity, it can be gender or whatever. So we select the sample based on the quota. So the sample fraction, 15 out of the thing or something like that. We select the specific characteristics or proportion within the population. Mainly we can see these things maybe underprivileged, like aswasuma, people who are getting aswasuma, for example, people who are differently abled, or some specific characteristics in the population, we get that quota. And then we have snowball sampling. So initial participants recruit more and more, like a pyramid scheme. It goes and go on and on with the snowball sampling. So we have more samples, like if you are in the gender-based violence or in studies related to these type of activities, you can't access some of these things, like for example, sex workers, or some underworld people, or very difficult socio-ethnic issues. It's very difficult for us to access them. Because of that, we have this initial sample that we can access, and they will do the work for us. They will reach those people, collect the data. So that's snowball sampling. This is useful in certain type of studies, like as I said, like gender studies or sexual violence or gender-based violence or whatever. So those kind of very specific cases, you can go for snowball sampling. Sampling biases are there. So sampling biases include non-response bias. Some will not be responding to you. Like in the case that you just asked me whether I have the ethical clearance to collect the data, some people would be hesitant to participate. So those type of things you will experience in the real world as well, right? When you try to collect data, people will be hesitant. If you go to like disaster-based data collection, people would be afraid to give data because they are afraid. They have some other issues, like in the field they might get exposed. Because of that, they are not really happy to participate. So you have to be persistent in follow-ups. You have to go repeat and do it and offer incentives and reward. This is not something that you have to do in terms of research. Like you get a positive answer, just give money, that's bribing. That's a different thing. But this one is like you take their time, and you have to give them some token of appreciation or something, just because they were present in your study. So incentives and rewards. In some cases, in foreign countries, you have this incentives and rewards specifically in the um, research methodology as well. Like, sorry, the grant itself will allow you to give some incentives and rewards to the participants. And then also, you have to make sure that your research is important, and you have to make it important per se. So volunteer bias is there. Some people volunteer more reliably than others, giving the sample. So if you go to like, I have been into this Express Pearl incident in the Negombo sector. So if you go there, some people would readily give information, like fishermen who are certain people, certain set of people will give you readily more information, but others might be reluctant to. So there is volunteer bias as well. So these are some practical things that you experience. In case of random assignment, different from random sampling, mostly used for experiments in quasi experiments. So what it does, it's randomly assigned. So random assignment controls who receives a treatment. Random sampling controls who is in the study. So those are two different things. Random assignment means like you are giving a drug or something. So that's assignment, some treatment. Random sampling is like who is to be in the study. Okay. So generalizability. How do you know that what you found in your research study is in fact a general trend? Does something really always cause that other thing? If A happens, is B really as likely to happen as you claim, or under certain conditions? So association versus causality, we will in-depth study this in the coming lectures. So I'll go through this with just reading through it. So education, whether actually it's related to the income. Some people, when I ask this, they readily say education is nowhere near the income. Some people get income much better than the people who have the education. So it's very difficult to say association. Okay. And I'm not a fan of the hard work concept as well. It has to be smart work. Hard work will make you sweat, but it will not really contribute to the actual outcome if you look at it. So it has to be smart work, not hard work, even though, I put it in the slide. Economic development and the roads, it is also something that indicates. So these are some association versus causality questions. And we try to answer these things in research so that we can generalize our findings. Right. So modeling, simulation, and emulation, I talked about this earlier on. Modeling is physical, tangible representation, scale models, prototypes, conceptual and mathematical, like Navier-Stokes equation. That's modeling. mathematical models will have like connections, the mathematics associated with like objective functions, decision variables, and constraints. What they are, they cannot be explained like in one word here. So basically, if you look at decision variables in your real world, a decision variable is like the amount that is in your pocket, for example. So let's say you have 1,000 rupees in your pocket. So objective functions can be the mathematical expression that defines the goal. So you have to maximize the savings. For example, you have 1,000 rupees. You have to say minimize the cost. Minimize the cost. So what you need to do is you have to take the bus, and you have to get your lunch, and also on the way you have to maybe pay some rupees to some, let's say you have to buy a loaf of bread. So so you have to do this. So there are certain costs associated with that. So when you do the mathematical model, you have some cost variables. So you can decide how you go. Maybe you, without taking a three-wheeler, you go by foot, saving that money. And then if you need two buses to go, maybe there's a one bus that requires a bit of more walking, maybe somewhere. Like in the case of university, you have to go to Katubadda. You walk to Katubadda and then take the bus from there, rather than taking 255 from the university. So those are like objective functions and how you minimize the cost. And then the constraints are like set of conditions that restrict the values the decision variables can take. For example, if you want to buy some say a thing that is like integer. So what you can integer in the sense like you have to buy an object like a coconut. Let's assume that half of coconuts are not sold. So you have to buy a full coconut. So that's a constraint. You have to buy in integer values. So you have to one, two, three, four. That's a constraint. So these type of conditions actually dictate your mathematical model. So these are what decision variables, objective functions, and constraints mean. The mathematical idea of your model. Simulations and emulations, I have discussed about it, so I will just go through it. And these are the extra readings. There are a few books that I have with me. They cannot be shared with you publicly. But if you are interested in this type of things, you can email me. I will send you the link separately. Because they cannot be shared. Right. So that is about the last lecture. So today we'll be talking about part 2. I will quickly go through the part 2 as well. So in the part 2, mostly you will find things that are relevant to questionnaire design. There are things that I wanted to sort of delve into in the lecture number 2. So there may be slides that are incomplete. So I will put the figures and other things associated with the teaching, and complete the lecture slides and then upload there. Other lecture slides are with me, but I have to bit of construct this one a bit. So I will include this and then upload. But part number 1, I will upload today to the Moodle. Okay. Right. So lecture number 2 is about data collection and questionnaire preparation. You have already seen a questionnaire. Can I know like how many of you have attempted the questionnaire that I have shared in the Moodle? If you can put it in the chat while I continue this, that would be great. If you have attempted the questionnaire on the Moodle, the link that I shared with you. Okay. Anybody who has attempted, can you have one, and others also? Yeah. Okay. 2. Others also, you can try it out. And okay, great. So you have some idea about as a person who is giving data, the person who is being interviewed or questioned, how you feel. So that feeling is important when we go into this. So the task of data collection starts after a research problem, and you have to define it, and you have to design and the planning of your methodology. Then you have various methods for data collection, primary data and secondary data. We have already talked about this in the previous slides, so I'll go forward because I spent 1 hour, 1.5 hours in completing that just to make sure that we are on the same page. So we have primary data and we have secondary data. So primary data can be collected from qualitative research, like observations, direct communication with the respondents, personal interviews, and also using quantitative research, like taking measurements, right? So that's primary data. You can collect the data from wherever you are. And from interacting as a fresh, like that's for the first time you are collecting that data, can be from experiments or from qualitative methods. Then secondary data, they can be available from published or unpublished data, and satellite images and other places. There are a lot of secondary data available. And data collection, the decisions to consider when you are collecting data, either primary or secondary, what to collect. Because when we say go and collect data, you don't go and collect everything that you find, right? It's unnecessary. You have to decide what to collect and then how to collect it. Because now, if you go there and if you want to find out about, let's say, how climate change is impacting on newborn babies, infants, maybe less than 6 months old, you will not be dealing with the infant themselves. You are not talking to the infants. How are you feeling? What is your name? And you don't talk to the infant. You will be talking to their parents, right? So how to collect the data from them is also something that you have to understand. So what to collect, how to collect, that's an example. And who will collect it? Because as I said early on in the snowball sampling case, it's very difficult for us to go and collect data from certain groups. So who will collect it? And when to collect it? So if you want to collect data about the impact of something during a certain period, like say express pearl incident, if you want to collect data about its impact on the livelihood of the people, you can now collect data about the aftermath. But if you want to understand how it has affected at that instance, you have to collect it at that point. So that's when to collect. So selection of data collection method will be based on the identified hypothesis or research problem. So what you really need to calculate and what you really need to understand, and the research design, because when you go to the field, you know your research design, and you have to rely on your design to collect data and the information gathered about the variables. So there are research instruments. So we call instruments here. When we have a lab instrument, for example, it is a lab item, an instrument. So the research instrument is a device used to collect data and facilitate variable observation and measurement. Depend on the data collection method selected. Instrument development requires a high degree of research expertise, because if you want to do a lab experiment, for example, if you want to measure a weight of something, if you want to develop a balance, you need to have certain expertise and understanding of it. So without that, you can't just build any type of a balance and then measure it. That's not going to work. So the same thing applies for questionnaire designing and research data collection designing as well. The instrument must be reliable and valid. So that's what research instruments are. So ways to find research instruments, you can find them from journals. So you have to look at them, read the papers related to your area. That's the easiest way, because if they have published those research, that means the method or the instrument that you are going to use is applicable, because that has been already applied. So from journals is the best way. From textbooks that describe various types of research instruments. Textbooks, for example, would be a bit more general. Sometimes it will be difficult for you to specialize that for your own work. So I would say journals and conference papers would be the best way. But textbooks also is a very nice way to make sure that you follow the standard procedure, like let's say if it is soil testing or any chemical testing, that is textbook method. Then you go combine or adapt one or more tools used by other researchers. You read and you observe others and then combine, develop own instrument to fulfill a specific need. Now that is a very interesting thing. As I said, let's say I told you about the climate change impact on newborn babies. So if it is about heat, right? Heat, the temperature increase, and we need to find out some impact that has on the newborn babies. We might be developing an instrument or a measuring device to go and collect the data, plus a different way of maybe exposing the child, the newborn baby, to different conditions and see how he or she reacts. And that is also a very specific way of collecting data. So that's an own instrument. To do that, you need to understand all those other things associated with the data collection and the research question. So types of research instruments in the case of, in the context of what we are discussing today, there are questionnaires, surveys, checklists, interview, observation, records, and experiments. So we discussed about experiments in detail. I'll talk about questionnaires and surveys. So questionnaires can be self-report measures, and interviews and diaries are also there. These are self-reports. In the case of questionnaires, you can find structured questionnaires and open-ended questionnaires. The structured things are like you have a specific question and the person who is being questioned give you an answer. So that's structured. Open-ended, you have a question, but the person who is responding has the liberty to give answers. So a lengthy answer, that's an open-ended question. So most common type is the questionnaire, a series of questions designed to elicit information, which is filled by all participants in the sample. It has to be filled by all. Can be gathered by oral interview or written questionnaire. So when I say I need to collect data by oral interview or written questionnaire, the I intentionally we have an idea about the person or the people or the sample that we are going to examine, right? Because if the sample has challenges for oral interviews, or we cannot ask them to write, that is also something that we have to think about. We have to think about how to develop this instrument, a different instrument, maybe a questionnaire, right? Like that. Okay, so it's something that you have to think about. Advantages, relatively simple, less time required, can gather data from a widely scattered sample. So I send the questionnaire to all of you. I can connect it without any delay. And it's very simple. Disadvantages, responses lack depth. Because I don't know, like if I am a respondent, I don't know about the problem being investigated. So I cannot give you that exact response that is needed for that depth. Also, I don't know anything about the subject, so I don't know anything. I can just give barely the surface of information. Then possibility of omitting or disregarding. Sometimes, if you have read Sherlock Holmes novels, you know that in some cases, some people have omitted or disregarded certain incidents because they think they are not necessary. But they are necessary if you look at the long term. So possibility of omitting, disregarding is something very common in this type of research and these type of instruments, data collection. May force to select responses that are not actual choice. So if you think about the undergraduate students, if we are giving them the questionnaire after the classes, after the semester ends, we give them some quality assurance questionnaire sets, right? But they are not giving responses because they are in a hurry to go, or they think that the lecturer might be personally coming at them. So because of these things, they are not giving the actual choice or actual their own real thing. So these kind of things are there. And also the length. If the question is very long, now think about the questionnaire that I shared. If it is long, now some of you said I have started but didn't complete. Maybe because it's too long, because you lose the interest. When you start doing it, you find something else interest. But think about that as well when you are developing questionnaires. And then the printing cost, if you are giving it as bills or the printed material. Data limited to voluntary information. If it is like a specific group, then it's voluntary information. Can be misunderstood as well. And as I said, literacy is required. So this is something we have to think about when we are doing this type of data collection. As I said, developing questionnaires require review literature, look through available questionnaire, obtain expert help. And I will show you some interesting thing here as well. Like there is something called Zenodo, like Zenodo, right? Yes, Zenodo. Here you can log in, right? And you can find a lot of data, like open repository for EU funded research outputs from Horizon Europe is a very useful website. You can go here. I think you can log in from your login details, and then you can find out a lot of details, lot of data sets available about many things. So it's a very valuable resource, in my opinion. If you have known about this one, very good, you can use it. If it is first time that you are seeing this, go and search the records. You may find something related to you, something related to your work, like climate impact on newborn. I don't know. You can just search, and something related to your query will appear, depending on your query, of course. So you can see you can go through presentations, data sets, a lot of things are there. So please try and see how it fits your work, how it fits your needs. Because you can that's what I say, look through available questionnaires and go through the literature, already published data. Select the question type, open-ended or closed question, depending on what you need. So yes, no questions may require additional information. Possibility of middle ground statement every time should relate to the topic under study. So you can't go and ask other things, too much of other things. You might need some other things to establish the context, but don't dwell on too many of those things. Like don't go there and like talk about politics, and then suddenly the villagers are so interested about it and they keep on talking about it and forget about the research, and they will not give you actual data, actual responses, because the pedagogy, the context has changed. So the length and structure, keep it brief. So you can read through this, and I'll briefly read. There is no such actual golden number about the size of it, but read it, give others to read it, your friends, your colleagues, and you also read it maybe today and then tomorrow after a break, and see whether it's actually within acceptable timeline, whether when you read it you can answer it very quickly or it's a breeze. Otherwise, if it is too hard, there's an intrinsic load associated with it. It will be difficult for the respondent. Okay, so keep it brief, and that brief, the length is a qualitative measure. Find out using your own experience. And then use theme groupings. Grouping questions together under a common theme heading helps the respondent contextualize the subsequent questions. So if you are talking about fruits, for example, if your theme is about fruits, don't suddenly ask about the price of cement blocks or price of sugar. If it is about fruits, those two questions are not related to that theme. So grouping questions together that under a specific theme would help the respondent to respond, and that is something that you can remember when you are writing research papers as well. Try to group your ideas in this thematic along this thematic um, arrangement, so the readers can easily shift between the themes. If you are discussing about something, keep that theme specific to that paragraph when you're writing. Okay, so contextualize the subsequent questions in the theme subgroup. Then counterbalance to avoid bias. The sequence of questions can bias respondents to give uniform answers without reading. Okay, so same thing will give, the same thing, you give 5, 5, 5, 5, that's it. To prevent this, designers should counterbalance questions like mixing positives and negative statements, because then the readers will read it. Uh, questionnaire is in the, not in the Moodle, it's in the announcements. I send it in the email. I can just read it. There's a link in the announcements. Counterbalance response scales alternating from positive to negative and negative to positive. So that is how you counterbalance. Then I will go through the green color points. The explanations are there associated with that. So this one should also be in green color. I forgot to put it. Provide a clear frame of reference. Prioritize clarity and simplicity. Provide a clear frame of reference. Avoid confusing or loaded language. Avoid leading or socially biased questions, and use ranges for sensitive and complex data. These are the things that you have to do all the time when you are collecting responses. Make sure that you understand your respondent better. Make it easy for them to respond, particularly developing questions that are capturing what you want, and at the same time making the person who is responding respond without any burden, like confusion. That will be very useful for you in the long run. So ask one thing at a time. That's also a green color. So match the scale to the question. Design must account for different question types: simple, factual, complex factual, opinion, attitudinal, open-ended. Factual questions might just need a yes or no checkbox. Open-ended question requires sufficient large text box. So open-ended requires people to write things. So there should be a space for that. If the space is limited, people will not write what they think. So you will be limited with their response, because you need that, because an open-ended question. Carefully design Likert scales for opinion and attitude questions. Likert scale is the most popular. So we'll talk about it in the coming slide. And also, trust and piloting is important. Build that trust, the trust between you and your respondent. Because if you poorly design this, filled with unclear, lengthy, confusing questions or typographic errors, they will think that what are they doing with my data? So they need to feel that this is something professional. So the trust should be there. You have to make sure that everything is in order. Always pilot the questionnaire. It is essential to pilot the questionnaire in a small scale initial study to identify interpretation issues, variations in biases, and structural flaws before launching the full research. Because if you don't know about, because you are researchers, you may be doing it as a lifelong research, then by all means you understand the context. But if you are doing it for the first time, you may be not aware of the people there. So you have to understand how they talk, how they react. So try to find out that little pilot questioning, and then build it from there. Avoid the confusion. Ask them whether this particular wording is what you want them to understand, whether they understand that actual thing. If it is not, then you have to reword it in a way that they understand. So that's how you have to avoid these structural flaws and the variations and interpretation bias. So having colleagues review the design is also a highly effective way to catch easily missed problems. In my questionnaire that I developed for you, there may be a lot of issues because I did it in a rush. I just wanted you to have that feeling of how to respond and what is the meaning of that, right? So if the respondent feels the same way, it's not effective. Characteristics of a good questionnaire must have well-stated title, should have statement of purpose, why you are collecting it, should assure confidentiality of responses. So I haven't mentioned it in my questionnaire, but you have to do it and say how confident you should be and how confidential your work would be. Design should achieve the objectives and should have clear direction, should not have overlapping answer options because it's a waste of space. If you have overlapping answers, that means you are wasting space and time on the paper. Should not have double negative questions because they are very difficult to understand. Avoid double barrel questions like asking directly whether you are happy to kill your better half, whether you are happy to be killed by your better half, like very direct questions which have no meaning and often will trigger responses with hatred or very subjective and biased responses. Design should facilitate easy tabulation of data because when you want to analyze it, you have to make sure that the data is collected clearly. Otherwise, you have to do it again. It takes a lot of time. So simple factual questions, complex factual questions, and opinion and attitudinal questions, open-ended questions. We have somehow talked about these things in one way or the other along this discussion. I'll go through one by one. Simple factual is like whether it's a yes or no response. Complex factual means you have to think about the question before answering. How many times, what is your favorite ice cream? That is something like a opinion, attitudinal questions, but also can be a complex factual question because if I give you vanilla, chocolate, strawberry, and hazelnut, for example, 4 options, and ask to put it maybe what is your favorite ice cream from them, then that is a complex factual question. You have to think about it. You have to perform some analysis and interpretation. And then opinion and attitudinal questions would be like, do you think that a country like Sri Lanka need to have this kind of big buses or metro buses only for people in this area or something like that? That is it can be an open-ended question and also it can be an opinion question. But in the case of opinion, they demand deeper concentration and wider variety of response alternatives because there could be multiple people answering you. Because of that, they will have different opinions and different attitudes to the questions. Open-ended questions, like, it's very easy because in the open-ended questions, the people, the respondents are the ones actually giving you the information. So you don't have to do a lot of things, but at this instance, but when you are doing it, when you're analyzing the data, it requires a lot of effort. Open-ended questions are very difficult when it comes to interpretation, but to collect them, maybe you can go to the field and ask them to give their opinion open-ended. That's something that you can do without any preparation as well. So aligning question types with scales. Remember, we talked about scales, ratio, interval, nominal, ordinal. So to align the question types with the scales, factual questions can generally be recorded as dichotomous variables like yes or no, checkboxes. So factual sensitivity, like age, providing a range is recommended as it clarifies choices and feels much less invasive than asking for an exact figure. If I ask the age of someone, it doesn't matter like if he's 32, 33, 34, 27, 28, we can give a range. Are you a person in 25 to 30, 30, 31 to 35, something like that? Because we necessarily don't need their age to that exact number. Open-ended questions require the researcher to provide a text box large enough to accommodate the detail. Because they are particularly valuable, they can allow unexpected issues to surface. They are like those petitions. You can give them the right their opinion about an open-ended question, and you might open up with many things. You never know. If I even give you an open-ended question about how would you find this session today, a very open-ended question, rather than asking were the objectives met or whether outlines were given, do you find this is relevant, rather than asking those kind of very specific questions. If I ask you how would you find today's session, that's an open-ended question, and you should be giving me the honest opinion so that I can look at all these things, allow, and sometimes I never know. Some might say my voice was not clear. Some might say my English was not clear. Some might say I need to include more graphics. So there can be things that I don't even consider. They would be unexpected issues. And that would be really good for a researcher because I can then go back and design in a way that is more prone or more resistant to the comments. So that's very good. Opinion and attitudinal questions are often measured. The literature, like how good you find it, how bad you find it, like those kind of scales. We'll come to that. But the thing is, generally, when you are developing Likert charts or Likert scales, they require some statistical understanding because you can't just, and these are like interval variables where you don't have necessarily a particular, say, most likely and more likely. There can be a difference between them. You have to understand the statistics behind this before you develop this opinion or attitudinal questions as well. So simple factual questions, as I said, yes or no. Complex factual questions, which mode of transport do you use most frequently? You have to think about it and then give an answer. So I come to this Likert scale. If you can read the part to the right-hand side, rating scales are used for opinion and attitudinal inquiries. To create a legitimate Likert scale, items should be developed and statistically tested to ensure they assess the same notion. Often, designers lack time or statistical expertise and rely on the visual checklist structure of a Likert scale. This shortcut affects data significantly. Since things are not statistically examined together, adding up scores across items is ineffective due to varying relative relevance. Researchers that utilize unproven Likert scales typically cite simple figures, such as claiming that 85% of users considered a feature unhelpful, for example. So, to avoid this lack of rigor, researchers should triangulate their findings using alternative methodologies, which means if you give a Likert chart, make sure that you have some other way to gauge this finding so you can understand how this opinion is related to whatever that is there in the study. So it's a psychometric scale used to measure attitudes, opinions. So you have 5-point Likert scale: strongly agree, neutral, disagree, and strongly disagree. But the problem is we don't know what is the margin between neutral and disagree. What is the margin between disagree and strongly disagree? So there is a 7-point Likert scale as well. Strongly agree, and then there is a somewhat agree before the neutral. There are somewhat agree added, somewhat disagree added here. So these are sensitive questions and intermediate points about the responses. These can be useful, but at the same time can be very difficult to interpret because these are like fuzzy. So if you are familiar with AHP, for example, there we are using SATI scale of 1 to 9. That is also very difficult to interpret. So all these opinions and numerical values representing your opinions, they are very difficult to interpret. So cafeteria questions. So these are multiple choice questions. Response, select a response according to their own point of view. So which of the following best represent your view on three-wheeler operations in Sri Lanka? So we have which of the following? And three-wheeler should be banned from using main road. Three-wheeler import should be restricted. Three-wheeler operation should be regulated. More concession should be given to three-wheeler operations. Three-wheelers provide a service to low-income groups. So all in all, some questions can be very tricky, and multiple opinions can be there about those kind of questions. So they have to think about from their own point of view and then answer. Then rank order questions. So it's like ranking in the order, which one is more important than the other. Rating questions are also the Likert charts, right? It's 1 to 5. More preferred, 5 means least preferred. So response bias, relying on people's memory of events and behaviors. This is what we observe when we go to the incident place, the actual field, because people have their memory and their events and the behaviors. They construct a world about what they experience. Okay, so that is response bias. Emotional states can prime memory. So if you were happy about certain thing, you might experience happiness emotionally. And at the same time, you may regulate your memory accordingly. Recency effects, time immediately before, and routines are deceiving. So, like if you have a certain way of doing things, you may, if you ask, like, have you seen anything unusual on that day? They might not be really referring because the routines they are not observing things apart from their routines. Then social desirability, assure participants that their responses will be anonymous. That is very important. Yeah saying means vary the direction of response alternatives, not always like yes, 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 yeah, should be some sort of alternative response. Neutral responses, the tendency of survey respondents to select the middle or neutral opinion on a scale, neither agree nor disagree, which we also do when we are in a hurry. So that is also providing a definite positive or negative response is the neutral response bias. There is no opinion in it. Sampling, convergence, converge, measurement, and non-response, these are general survey bias. This was is response-related bias. These are the general survey biases. And design is the key. Format of the questionnaire, booklet printed, or the online question ordering. Earlier questions can prime answers to later questions. As I said, if you are talking about fruit salads, then if you talk about ice creams and then suddenly talk about the price of cement, then they are not really related. So they are priming, earlier questions are priming the reader towards more towards food and food and leisure and those things, but suddenly asking the price of cement, they are not related. So that is important. Page layout, group similar items and use consistent fonts, response categories. These things are very similar to your scientific writing. As researchers and graduate students, always think about this when you are writing your research as well. And pre-testing is very similar to pre-reading, conducting aloud with volunteers, how they respond. Common problems, avoid complicated and double-barrel questions, as I said. Navigation is also important, easy to follow. Open-ended questions, the allowed size to write it, and incentive, but amount differences have little impact. You can give a toffee even, that feels good to the respondent, like a pen. It doesn't cost much, but it gives a little belongingness, something, something that you receive for what you do. Even token, a small little thing to wear, like a pin or something, that would be a very good thing. So decide the information required, define the target response, choose the method, decide on question, develop the question wording, put questions into meaningful order, check the length of the questionnaire, pre-test it, develop the final survey form. So you have the comfort, readability, cost. You can put it into that. Questions and topic can require same response like this in a group matrix. So I have given some ideas about the interviews as well. I will upload this slide once I fix some formatting, so you can read it better. But all of you are familiar with interviews or in one way or the other. So I'll allow you to read it once it is fixed. But I will come to this thing. Interviewing style and setting, adapt a student-tutor approach, choose a natural setting, remain extremely flexible, which means you have to make sure that you give more time to the respondent when you're interviewing. Don't try to interview someone if you are doing an interview. Like you are the one, like if you watch YouTube, you can see a lot of people who are interviewing, they want to speak more than the person being interviewed. So that is wrong. So limit your speaking time, but don't give like answers. Like when you see nowadays big politicians being interviewed, asking the answer first, like give the prompt, and suddenly they will give the same answer. Avoid leading restrictive questions, guide without forcing, and maintain eye contact, not like in the first image, but like in the second image to the right hand side. You have to make sure that you give that freedom to the interviewer, but not in this first way, but in the second way. And manage recording anxieties. While recording devices can initially intimate response, so it just becomes okay after a while. Always keep a pen and pad ready as well. Recording device is important because when you're talking to someone, keeping the eye contact and writing might be intimidating. The person might think that you are like interrogating him or her. But if you manage your eye contact and then keep the recording device, you have a natural conversation. So observations, records, and so I have something. So these are some slides that I want you to read. So I will put this and upload. So last slide is about the questionnaire, administering the questionnaire. To gather information without error or bias, have standardized interview procedure from one subject to the other. Probing procedure should be uniform. Interviewers should have prior training for a uniform approach, and gestures and body language should be given particular attention. That is for administering the questionnaire in the interview form. So I have added, I will share this slide with you, but I have added this little link in the bottom. When I share the presentation, you can also visit this, but I will send this to the chat anyway, so that everybody meeting group chat can visit. So this is a little link to a PDF. So if you visit this link, so this is about JICA project, Open JICA report, a PDF file. All right. The project for rural water supply in Republic of Gambia, questionnaire for sample household survey. I include this because it's a professional one and it's already been implemented. JICA study team has developed it. So look at this and try to see how a good questionnaire might look like. It's very neat, and you can include a lot of details, right? And the question being analyzed, how you are collecting data, and all these things are included in this particular questionnaire. So it's in English, but you don't feel like you don't need a lot of complicated English to understand it. You can understand, and also the numbering that has been given. So if you go to, let's go to our Kobo toolbox. So there were 21 responses. Thank you for that. And you can see, so now this is what I wanted to share with you. Reports. So I wanted to do this analysis with you. So I can, when I get the full detail, maybe others who have forgotten or could not give your details, participate in this survey, try to go there, and in the link it is available under access UOM. If you visit this website, the link is available under announcements. Example questionnaire. This is the link. We click on this, it will direct you to this questionnaire page. So you can read it and answer it. So it doesn't collect your personal details. So academic background, only age, gender, and other things are there. So we can see all of you have declared your gender. So we have 66% female, almost. We have 2 females per 1 male. And then we have domestic students, Sri Lankan students, master's degree, doctoral, and bachelor's. So this is, I think, again, think about the question as well. What was the question and what is your response? And the type in the STEM and arts and others. And then you have first year, final year, second year, third year. So full-time and part-time students are there. So it's a very nice data set. We'll look at this when we come to our data analysis part. That is why I wanted this to be filled. So we will be talking about a data set that is close to us, right? And it will be really interesting. So I have the report already, but once everybody get the chance to fill it, we will enjoy this in much detail in a detailed discussion about the data analysis and how we can use different techniques to understand different aspect of this in terms of quantitative analysis. All right. So the link is available here, and today's recording, I will also upload that into YouTube and share the link with you so that you can easily watch it. Why I upload it in the YouTube? One thing is I can share it with others who are interested in, with my students as well. And the other thing is you can actually fast forward, or it's easy for you to download if you want, or you can watch it anywhere you like. So that's why I put it into YouTube. Okay, so with that, we can conclude the lecture number 2 as well. So this is the whole thing. Next time, we will talk about, next lecture is going to be lecture 11, data validation and reliability. That's where we talk about statistics and in detail about how we take this data and how we take it to analysis. So bear with me, I will organize this last bit of slides and upload it to the Moodle, but I will upload the first lecture to the Moodle maybe tonight or tomorrow, hopefully. So you can go through them. Okay, so with that, I can conclude on time, and I'm going to stop my share and stop the recording as well. Now I want your opinion about whether it was a useful one and you got something from it.